Hello, Andy. Just going to show you our little Velocio Ace 222 PLC with the simulator board. So just show you from the overhead view here. This is the actual PLC itself, and then this white thing is the simulator board. I just mounted it on some plexiglass and just put some rubber feet on the bottom so it's a little bit more sturdy. Yeah, so these are all my digital inputs, digital outputs, and then analog inputs. Also found this case from home. It used to be out of one of my Dremel tools that I've got in a different case now, so I just cut the inside out and put some foam in there so then I can take it back and forth home. And then here's just a little set of push buttons I created just that plug into these little ports down below. I don't know if you can see that. Looks a little dark down there. Anyway, that's what that is. So that is the PLC itself, and you'll notice I'm in my office, so the portability of this has made it awesome to learn with. And then the software is fairly easy to use, so I just got that pulled up here, and what I was going to do is just show you how to create a little program right at the beginning. So you could just create a new program. It opens up a dialog box down here, and we'll just call that demo 1, because I believe I already have a demo in there. And we'll do ladder logic, just to something you're probably more familiar with in the flowchart. And okay, so the first thing you do is you start over here, and you just got to get your communication set up with your PLC. And you do an auto setup. Now it finds it. Just go down here to next. And there's your ladder logic. So there's your first rung on here. Unlike the PLC 5 program, the one I was using, RS Logix, there's no end rung. So it just starts with this first rung. And one of the cool things about it is you can just re-tag all your addresses and call them what you want ahead of time before you start. So it kind of makes it easier to locate them afterwards. So I can go into my input bits, and I can just call switch 1, and I'll just hit OK. Actually, I'll go to my output bits here, and then I'll pick D1 is my first output. I'm just going to call that lamp 1. Alright, so now I have my 2 that I wanted to work with, and I'll go grab a normally open input there, and switch 1 way down at the bottom here. Hit OK. And then as soon as you do that, it does start the next rung. So, it does start building itself. You don't have to add that in. And then we're looking for an output or a coil here. So just add that in and go find the one I wanted to use, and that was called lamp 1. Hit OK. So now I actually have a very, very small program built into there. And to do that, you hit the Velocio button right there, and then you run it. So now the program is ready to go. And so if I'd programmed this switch here to operate that lamp there. And it works. Awesome. Okay, so again, really, really simple program. Almost too simple. But anyway, it shows you what happens. The other thing they have is a debug mode, and it actually has a picture of a bug, which kind of simplifies things. And anyway, you can follow the logic through. You can follow what's happening rung by rung, and you can actually make it stop at a particular rung if you want to just follow it up to a certain point. So if you've got lots and lots of rungs, you can just put a little marker on there, and it'll only go up to the rung you want to take a look at. So if you've got a bunch of timing sequences in there, it'll actually won't do any of them. You actually have to click through the timing of them. So that makes it nice. So you don't, if you had something in there like half a second and you couldn't catch it with your eye, you actually have to, all the timing sequences have to be, you know, clicked, mouse clicked through to see them out. Anyway, I'll hit the switch there. It goes green, and my output goes green. Take the switch off, red, and red. So you can see how simple that works. All right, so what I was going to also do is just show you another little bit of a different program. Anyway, I'll stop this one, take it out of debug mode because you can't really do any changes if you're in debug mode. Wasn't going to do any anyway. I was just going to open up a new one. So just go over to here to open up an existing project. And I've got this one called Overhead Door. So again, that's a second year lab that we do with relay logic. Open that up, and there's my program. So we've got an up button, stop button, an interlock with the down coil, and an up limit to shut everything off on that one, holding contact, and then we've got a safety edge to bring that door back up if it hits something. And then on this rung here, we've got our down button, stop, up coil for the interlock, down limit to stop it, safety edge to stop it, and then down coil here for holding. So what I'm also going to use is this push button setup I've built here, and I'm going to plug that in so we actually just have some push buttons. And I believe this one here is my up, down, and this is safety edge. Okay, so I will put that into, I'll program that in, I'll run it, and it'll also go into debug mode. So the stop button is in its normally closed state like it's supposed to be. I will hit the up button, and you'll see it goes green, and then the holding contact stays in, and notice my up coil is energized. Okay, so then I will say that the door's reached its travel limit, and now the up limit went red. The up coil holding contact is off, and the coil holding contact is off, and the up coil is also off. Okay, and that up limit would stay in that position until such time as it starts going back down. So now what I'll do is I'll press the down button, and the holding contact stays in. Now the door is going down, so therefore my up limit would go green because it's not hitting that limit anymore. And then I would wait for a down limit to get activated. So the door is at the floor now, and it's completely closed. So my down limit's been energized or activated. Down coil is activated, so it opens up, or sorry, it's deactivated, and that's deactivated as well. All right, so let's try the safety edge thing. So I'll start moving my door up. Okay, and now my door is completely all the way up because of my up coil. Again, this is all just simulated. Don't really have an overhead door in my office. So now we'll just assume that the door is going to come down. And now you can see that my down coil is energized and my up coil is de-energized, just like it should be. And then I will activate my safety edge. And you can see that the up coil is now activated. The down coil, I'm holding this in too just so that it doesn't go away, is deactivated. And you can see my safety edge is, the closed is now open, and the open is now closed or activated. It's a 1. And I'll take my fingers off that. But anyway, it stays in that because the up coil, so it's basically going back up. My LED for my up coil is energized, and then if I hit this button that acts as my up limit, it will stop that. I also have a stop button built in too, but it just is pretty elementary. All right, so that's what that looks like in a ladder logic. And I was just going to show you some other stuff on the side here. So here's where all of your user inputs would go. I don't know if you can see that very well. It's a little blurry. Anyway, try to just doesn't pick up the monitor very well. So here's your coil. You actually have a calculator. You have a copy function, which speeds things up a little bit. Your counters, data log, drum. I'll show you that. That's really cool. And then you've got some motion in, motion out, PID stuff. And whoops, I guess I didn't. And then you got a pulse width modulator, so I'll show you that too. And what else? You got a clock. You can actually do subroutines. So if it gets really large programs, you can build subroutines that run inside the actual program. All right, so let's stop this program and open up another one. I'm going to do the overhead door again, or something. I think I called it garage door, but I called it flow. Open that one. And here's what that exact same program looks like in flowchart functionality. And works exactly the same, just looks a little bit different. So it depends on how you think, whether you like answering yes or no questions, how that will go. And again, I can program that in, run that, and then I could debug mode that, and I could operate that. And now my up coil is on, and it goes around through and just keeps checking and asking the yes or no questions, and then depending on what the answer is, it'll go through to various coil functions here. These are all coils here on this side. And nice thing about this too, either one, flowchart or ladder logic, is that you can print them. And I think I actually have a couple copies here. I'll just show you. So you can actually print them out. So if you were to get your students to do it, these are both the garage door ones that I did. You can actually print them out. They're fairly easy to read, legible, and again, you can get the whole program in there. Pretty nice function, I think, to be able to print that off. All right, so that's that one. I'll show you some other ones before we go any further. Another cool one is the dimmer pulse width modulator. And again, there's not much to this program. I'm going to, once I program it, I am going to be controlling the brightness of this bulb with just some functions here that are in the flowchart here. And this one here is just basically the timer in milliseconds that it's going to take for that light bulb to get to its highest degree of brightness. And then this is actually a ramp function. And so you can control whether it's like a linear straight line as for brightness, or you can actually make it to sort of an exponential curve if you want. Okay, and then this just tells you which light I'm going to do it in, and that you have your on time in milliseconds for the brightness control. Okay, so again, it's this one here. If I hit the play, you're going to see that bulb get brighter. And then go out. 7,000 milliseconds or 7 seconds for the whole package to go. Okay, so that's one little cool function. So that's a bit of your pulse width modulation. I'm also going to show you motor stuff, motion control, a little bit later. I'm going to stop this program. I'll open up another one. I'm going to try and show you this one called, I didn't label it correctly with the right name, but it's a drum function that's found in the ladder logic. And what this does, I just got this input here to start this drum, and a drum actually is it's like a computerized rotating drum, like a music box or something like that. So again, I've got these controlling the outputs, the LEDs, and then these I've labeled them all here, and this is when their on function is going to happen. And you can see that they've got obviously a definite pattern to it. So if I program that in here and then run it, it'll only go when C4 is activated, which is this push button here. And then that's its drum. It just keeps rotating through. So as soon as I take my finger off, that's where it'll leave off. Let me continue. So that's that drum, and that took me about 2 minutes to set that up. And you can do all sorts of things with that. And again, you don't have to do them in nice fancy sequence like that. You could use that drum function for so much more. And I don't know if I have a whole lot of other really cool stuff other than the motion control, which I'll definitely be showing you in the next video. Peace out.